Hello guys. In this particular session, we will be looking into Solow model. Solow's model of economic growth is tremendously important because it was the basic model which tried to explain the economic growth, and it also has the macroeconomic implications. And before we go into it, we must also see that Solow model became quite useful to explain the growth rate of various economies during 19th and 20th century. Okay, and Solow got the Nobel Prize for his growth model. So this we have looked into the Solow's model, just a brief history about it. So now we will look into what are the assumptions that were taken by Solow. So first assumption was he took neoclassical production function. Neoclassical production function. So he assumed neoclassical production function. It means your production function will look like this. This is y. Y is a function of capital. Okay, so this was one of his assumption, that there was a diminishing return to factor of production. I would say diminishing returns to factor of production. Okay, then he also assumed the economy to take some assumption from Keynesian model. What he took y is equal to c plus I. Okay, and assumed at equilibrium investment will be equaling to savings. Okay, so these are the broader thing that we need to keep into mind, and the most and the most very important thing that we need to look into it is exogenous model of economic growth. What does this mean? Exogenous means the model's growth is exogenously determined because savings rate were exogenous. Saving rate were exogenous. Also, technology was exogenous. So these were the two things that we need to keep into mind while we read about the Solow's model of economic growth. It was first major contribution and first study which was done in the field of economic growth, and which actually changed the paradigm in economic growth models. Now we shall look into it. Firstly, we will say production function. Like let's say we go from supply side. What we will write in supply side? We know production function is like function of capital comma labor. This is our production function. So what we can do, we can change it to like this: y is equal to a k alpha L 1 minus alpha. Assume it to be constant return to scale. Why constant? Because alpha plus 1 minus alpha tending to 1, because alpha and alpha will get cancelled, so it is equivalent to 1. So it shows this is a constant return to scale model. Now what we'll do, we will divide it by L on both sides. What it will give? K alpha L into L by alpha, since we have to divide by L, that I have taken. So what it will make? Now we will write it smaller y to show it is per capita output. Now this is A and this is K by L whole raised to the power alpha, and L will get cancelled out. So we can write small output a function of K raised to the power alpha. We can assume A to be 1 for our simplicity. So we can write a production function that is per capita output is a function of per capita capital, and it is also the having the factor of growth, that is lambda, not lambda, actually alpha. We can write alpha, so we can remember it. So this is equation 1. Now we will look into since we know change in capital stock is equal to investments that are done in economy minus the depreciation which are taking place in the economy. So this is if we can intuitively understand what would be the change in capital stock, it will be equivalent to investments minus depreciation. So if we add investment minus depreciation, what we will get? We will get net addition to capital stock. Okay, this is what we have written in per capita terms. This model we also assume, since savings equal to investments were there, so it has to follow is equal to smaller s f of y. So since we have derived y, so we can write f of k alpha. So let me change it to something like this. So let me write it like this. This is nothing but y. Okay, and at steady state change in capital stock per capita will be 0. So we can infer that I is equal to k and I is equal to s of fk delta upon k. So we can do some kind of rearrangement. Here we will get again s upon delta is equal to k upon f of k, and this is the equation of steady state. Equation of steady state. Now we can draw the diagram to analyze it diagrammatically. This is small k, which we written as capital K by capital L. Now we will write the depreciation line. This is delta into k. Delta into k because it is passing through origin and there is no intercept. This is y, that is capital Y by L. Now we have to plot the production function. So we have plot a production function like this. This is f of k raised to power alpha, and since s of flk is equal to del k at the steady state, so we have to plot another line like this. This is s of f of k, and this is equal to lk as I have showed in this equation particularly. So at the steady state they are equal. So this is what k star. Okay, this is what k star is all about. So we can say at k star this much amount of investments will be there in the economy and this much amount of consumption will be there in the economy. Okay, so again we can write y is equal to c plus I, as we are writing, and I will be equal to this distance. This is nothing but SFK, which is equal to as at K term. So at K star we are having our steady state. At a steady state, the thing that we need to remember is our growth per capita is stagnant. Okay, growth per capita is stagnant at a steady state. So we can say, therefore, in Solow model, the growth rate per capita at steady state becomes 0. Growth rate becomes 0 because there is no growth rate at this particular point, and our economy gets up to this rate. So this is how the Solow in his model tried to explain the Solow's model of growth. There have been certain variants which said, what if the population grows with rate n, and what if there is a technological growth. So these are the latter variants. We will be looking upon them in the later lectures. In this particular session, I just want you to digest all this what I have just told you. Just start with basic Solow model. Write the assumptions that I have written here. Just remember, assumptions are important. You need to be very thorough about the assumptions which are here. And so remember these assumptions. Neoclassical, you should highlight it. Then diminishing returns, two factor of production, Neo-Keynesian model, assumption of demand side was there. At equilibrium, this was assumed. Exogenous model of economic growth is very important. You have to keep in mind this exogenous word is very important. Sometimes in the examination they don't explicitly tells that it is a Solow model, but they says it is an exogenous growth model, so you have to identify it with the Solow's growth model. Then saving rates are also exogenous, they are not determined in the model. And technology were also exogenous, that is, technology is not getting impacted by the growth. And then we can start solving by assuming the A to be 1 and assuming constant underscore as you already assumed. Then we got the production function y is equal to k alpha. We can use it in the later time. Then we can show the the net addition of capital stock equation, where we say change in capital stock per capita is equal to investments per capita minus the depreciation per capita. And in the steady state, del Q will be 0, so we can rearrange it to get I is equal to S is equal to Sy. Now the steady state, we can just simply put these things that we have got in the earlier side. So I is equal to I that I have written here. I is equal to that I am writing about del K. Why I am writing about del K? Because in the steady state this equation will hold. And I also writing that I is equal to saving is equal to investment. So saving, this is saving the economy, this is per capita saving, this is per capita investment. So I am equalizing it, just matching it. So at a steady state we are getting this equation. This is Solow's equation. This is Solow's equation. Okay, and then you can plot this diagram and you can tell this is capital stock per capita, where economy will finally converge, and here the growth rate will be 0, and correspondingly this much amount of consumption will have in the economy and this much amount of investment will be there in the economy. And this is how the Solow concluded is the model. And there are later variants which we will be discussing in the later course of the video. If you have understood it, you can give it a positive reply in the comment section. And in case if you face any issues, you can very well also comment there. We will get back to you on it. I hope you all have enjoyed. Thank you.